Okay, we'll get started with the main topic. Once again, my name is Dan Yeaw. I'm a systems engineer. I work at Ford Motor Company. I'm a host of Michigan Python right now. I'm really excited to have you join us. I'm going to be giving a talk on Python project management with Poetry, and really looking forward to this. So we'll go through some kind of overview of what what it means to do project management and what Poetry can provide, and then we'll kind of walk through some examples of setting up a project from scratch. This is a XKCD comic on Python environments, and it's kind of a joke seeing, hey, all the different ways you could connect your environments and different tools. And some of those we're going to be talking about, like pip and easy install and other things, and all the different environments. So this is what we want to avoid. We do not want our Python environment to be a super fun site like in the comic. So let's talk about packaging. As a developer, you want to be able to create some source code, write something useful, and then put it in a package for others to make use of. And that's called a distribution. And then once it's in that package that others could make use of, then we want to be able to put it up on the internet to some software provider, and then allow others to get that distribution and then move it onto their computer to have working software that they could make use of as well. And this is really what makes Python so powerful as well. There is so much built into the standard library, but then on top of that, the Python package index has hundreds of thousands of libraries for you to make use of, like things like requests and class and Django and all kinds of libraries and frameworks that lets us build awesome Python applications by using some code from others. So this is why we want to be able to package our app both as a user to be able to make use of this huge source of libraries, and also as a developer to be able to share your libraries and packages with others. So we're gonna kind of talk about the history of that a little bit and what those different use cases are, and then also give some examples of why a tool like Poetry is so powerful. This is a brief history. Year 2000, there was Python 1.6. There was a tool called dist-utils that was added to the Python standard library. And the purpose of this was just what we kind of talked about, be able to distribute your Python source code and then build it on your own computer based on what someone else shared with you. And then in 2004, an improvement to that came out called setup tools, and setup tools shipped with an installer called easy install. Probably a lot of you are familiar with pip installing something. Well, before that, there was something called easy install. You could easy install something. And then also with setup tools came these distribution formats. So one of the other things that's really powerful about Python is you can not just share Python source code with others, but also you can build libraries that are based fundamentally on, source code built in other languages. And a lot of our ecosystem, whether it's like GUI toolkits or it's data science tools, are often built in other languages underneath, like C or even Fortran or C++ or other things that we actually need to compile. And having a distribution format, in this case, egg came out, allows us to compile libraries and distribute them with things beyond just Python code. And that unlocks a lot for users as well. In 2008, setup tools kind of upgraded from easy install to pip. And probably a lot of you are familiar with that. So you can pip install requests and get requests on your computer. And then in 2012, the egg distribution format was upgraded to something called Yeaw. And a Yeaw is a zip file with metadata which provides this binary format for you to get, once again, the distribution of software, which could include Python or other languages. And in 2018, about 5 years ago, as we're giving this talk today, Poetry came out, and it provided extra capabilities that aren't included with just setup tools or just pip. And we'll talk about some of those extra capabilities that kind of lets you manage your whole Python project using one tool. We talked a little bit about sharing code with others. So the easiest way to share code with someone is you just create a .py file and a standalone module, and then you can give that to someone else. Like you could email someone a .py file or put it on a jump drive or something like that and say, or upload it to your website and say, hey, here's a Python file. It's a script that does something. You can go ahead and execute that and have that functionality as well, as long as you have Python installed on your computer. There's also something called an sdist, a source distribution. And this is for pure Python packages. So beyond just a single module, you could distribute your whole library of Python that you've built in a source distribution. And that comes in a tar gunzip file and has some metadata that comes along with it as well. And then the other way is, once again, with this Yeaw. So these are binary Python packages in this zip format that can include both pure Python and other things as well. And so those are like the different formats. And then that's kind of these distributions on that slide where you get a distribution, whether it's a standalone Python module or a source distribution or a Yeaw, and then you can install it on your computer as well. The kind of legacy methods we had in Python for this is a setup script called setup.py and a configuration file called setup.config. And when you would go to install this Python library, it actually execute, this is Python code, it would execute this setup configuration file, and then it's able to build and configure your Python that you're trying to install using that setup.py and setup.config, and I'm sure a lot of you have seen those in projects before. And then another common thing is a requirements.txt file. On each line in that is a requirement, another library that's needed to run a program. And you can also tell in that requirements.txt file what version of the library is need to be installed. I'd say those are kind of like legacy methods. And we're moving towards newer file formats that can replace those and have a lot of advantages. So I'm going to introduce poetry. So kind of the tagline for this is Python packaging and dependency management made easy. And it has, I think, three main use cases. One is for installing packages. So you want to be able to install some other library and make use of it in the software you're building. So if you're building a Flask app, you want to be able to install Flask and say, yep, this is something that needs to be installed alongside this so I can execute my Flask app, as an example. Managing application dependencies. So this is also very important as you start adding more and more dependencies to your project. Some of your dependencies are going to depend on other libraries that must be installed as well. And maybe two of your libraries depend on the same library, and they may even depend on different versions of the same library. So being able to manage your application dependencies and really ensure that you're got this reproducible environment is really important. And that's another thing that poetry allows for. Kind of that's tracking of dependencies and understanding what's needed to like build your software and have this deterministic build. So every time you build your software or someone else installs your software, you get the same result. And then the third thing is for packaging your Python projects. If you want to share it with other people and create that distribution and then upload it to a place like the Python package index, PyPI, then you also want this ability to do that fairly easily, to package it up into a source distribution or a Yeaw, and then upload it to PyPI. Okay, that's enough with some slides for now. We're going to go ahead and jump into like a demo that we can work through. So maybe before I get started too far on that, is there any questions, anyone? All right, I don't see anything in chat. Don't hear from anyone, so we'll keep on rolling then. So as you can see, I have like this really simple example that I've created. So there's a folder called Flask tutorial. So I'm just going to create this like simple Flask app. You could do it for any type of program. So we could have just wrote print hello world or something as our library, or yeah, we could do web scraping using Beautiful Soup, or I don't know, hit an API using requests, or it doesn't matter what type of program we're using, but we can use these same methods. So this just has it has a package called Flasker in it, and it has this init dunder init.py file that gets, it's the only file in the app we're building here. And this is really Flask hello world example. So we're importing Flask, and then we create an app with a main function there. And then there's some configurations and setup for SQLite and testing for configurations. And then really there's just one route for our Flask app with a function called hello, and it returns hello world. And then at the end, it returns the app from this main create app function. So if, I know I went through that really fast, but probably the Flask app hello world isn't as important. It's just an example for something we could use Poetry for. I also have a README file, and it's just says that app is called Flasker app. So it's pretty basic, but the rest of it is just a couple files in our project, right? So we're just getting started with some new project, and now we want to be able to assign things like dependencies, set up our environment, and be able to share a project with others, and all the kind of things we just talked about, right? So first of all, we want to install Poetry. So what I would recommend for that is there's a tool called pipex, and it allows you to install Python command line applications that are installed in their own kind of isolated environment, and then they become available on your command line for all your projects to use. And so the way we're going to do that, I'm in Windows, so I guess I'm going to use the py command, but if you were in Mac OS, you could use Python-m, but I'm just calling pip here. We talked about that. So pip is going to go out into the Python package index, download pipex, which is what we're looking for, and install it. And I'm installing it on the local user account. So I'm using the user here. So we're going to go ahead and install pipex. So it went, some of these things I already had ready, right? But it's using cached versions from PyPI, but it's saying, hey, I found pipex, and I went ahead and installed it. If I didn't have the packages cached on my local computer, then I would have gone out to the internet and done it. And so now we should have pipex as a command. And then pipex, I want to install Poetry. And once again, this pipex is creating this isolated environment for Poetry to run, and then it's available on my command line all the time. So we can always run Poetry. I think that's like a really nice way to set up some of these command line tools like Poetry, or if you want to use Black for formatting, or virtual env for setting up virtual environments and stuff like that. It's really nice for that, or Flake8, or any of those kind of like command line tools use a lot. So it says these apps are now globally available, Poetry, and install the latest version at the time is 1.4.2. So we can test that out and try running Poetry. And we got some command line stuff there. We got to check the version, which we'd expect is be correct. There's one configuration that I'd like to do with Poetry before using it. And you only have to do this once to configure it. But normally Poetry installs your virtual environment, and a virtual environment is a kind of isolated place where all your packages are going to be installed for a project. And so Poetry does the virtual environment management by itself without you have to manually create a virtual environment. But I prefer my virtual environment to be local in my project so I can see it, I can delete it if I want to and stuff like that. By default, Poetry creates it in a common folder outside of the project. And it's just a preference of mine. I rather have it in my project itself. So I'm going to configure Poetry to put it there. But this is totally optional. Probably other people prefer to have all their virtual environments in like the common folder, but it's just not my preference. So I'm going to go ahead and do Poetry config. And then the rest of it is this virtual ends dot in project true. So this configures Poetry to put the virtual environments in the local project. But we don't have any dependencies, or we haven't like set up this app yet. So we're going to go ahead and do that first. And the way we do that is we do Poetry space init. And so it's saying this command will guide you through creating the pyproject.toml config. A .toml file is a configuration format. It's human readable, so you can edit it by hand. And it's kind of this new format that is standard across the Python ecosystem. There was a Python enhancement proposal that standardized this format. And it's kind of this new modern way of setting up your project options without using the setup.py or setup.config files or requirements.txt files. And you can also configure other tools using the same file. So like things like Flake8 or Black or other PyTest, you can put it in the same configuration file, which is really nice as well. So our package name here is this Flasker. So I'm going to go ahead and put the package name in there. It's giving me like a default version of semantic version of 0.1.0. That's fine. We could add a description like hello world Flask app or something. I'm going to change this to like my personal email. So this is the author. You can add a license, and you'll need a license if you're going to upload it to PyPI so other people can make use of it. You can specify your compatible Python versions. And what Poetry uses for specifying dependencies is a few different formats, but one of them is this kind of tilde. And that allows you to have the latest version. So it'll be 3.11, but it'll also allow, if new versions come out, for them to be upgraded until it becomes like a major version change. So that I'm using Python 3.11 and say, hey, I want to use all the new version features of Python, and that's okay to say, hey, it's compatible with this. If you're making a library for others to use, then you may want to include some lower, like Python 3.8 and 3.9 and 3.10 and 3.11, or a little bit of like historic versions, so it's a little bit more compatible with others. And it's asking if we want to define our main dependencies interactively. I'll go ahead and say yes. So we can now search for Flask. And if you go to the first one, which starts with 0, you can see the package name Flask is the first thing. So we can just go ahead and say that. And it's asking for a version constraint. And so we want to use the latest version. So the latest version of Flask is 2.2.3. And this will, once again, the tilde allows the version to update until the major version changes. And then if we want to, we could add other dependencies as well. So this is just an example of the init. We won't add anything else right now. And I don't want to define any development dependencies right now. So I'm going to click no. And then I'm going to tell it to confirm generation. So we've now initialized our project we're working on. So you could do this for any time you start a new project, right? So the pyproject.toml that was created here, you can see the different things. So there's some metadata that was created. And if you hold on just 1 second. So there's some metadata that was created here that gives the name and the version, and the license and the README. And those are the main things you would need for a project. And so it sets that up already. And then the Poetry dependencies. So it's specifying the Python version that was compatible with. It added Flask. And then finally, the build system. So Poetry separated its build backend into something called Poetry-core. So if you're installing an app that uses Poetry, it'll have that pyproject.toml. Then when you go to install that, it'll say, oh, this requires Poetry-core, which is just a single small library that's able to build a Poetry project. And then it will just install that one library to build it and then run the build command on your project. So pip can install this project out of the box. You don't have to do anything special. So this is this pyproject.toml. So we have now specified our dependencies. We have Flask as a dependency, and we're ready to go now. We have a project that's operational. So what we can do is we want to install our project, right? So we can go Poetry install. And Poetry install, it says it's creating a virtual env Flasker in .venv. And the reason it did that is because, remember, I told it I wanted locally to have my virtual environment because that's what I prefer. If you didn't do that, then it would put it in a common place, right? And then it's updating the dependencies and resolving them. So it's looking at our dependencies, which is Flask, and saying, okay, what does Flask need to install this library? And so it installed 7 things. You can see these are all the things that Flask needs. And it also says it's writing a lock file. So what's a lock file? So something Poetry has is this file called poetry.lock. And what this is it takes every single dependency and kind of freezes all of the versions of that dependency. So it's saying, hey, click is version 8.1.3. These are the Yeaw and the source distribution files. Here's their hashes. And then it goes on down like, okay, the next dependency, what is its exact version? What is its hashes? And it does that for all the dependencies. And it also does that for all these dependencies for those libraries as well. So it's a lock file. And then what it allows you to have is, once again, these deterministic builds. Instead of like a requirements.txt file where you just specify, hey, I need a library, it is giving you the exact version of the library with exact hashes every time until you decide to update your dependencies for your project. So anyone installing your project will get the exact same versions of all the libraries it installs as well. And so it's installed all the dependencies. It wrote this lock file. We can now commit our pyproject.toml and our lock file to our source. Our version control using Git. And so we've installed this project now. Now we want to run our kind of sample here. So one thing you can do, once again, it created a virtual environment and handled all the dependency installation for us. So we can do Poetry run, and then we can go Flask. And so we can say Poetry run Flask, right? And I think I think the main command for Flask is Flask run. I don't think that's going to work because I think it wants us to specify. It says could not locate a Flask application. So we're going to do --app and then our app name, and then do run. So what is this doing? We're telling Poetry to run a command. So it's running it from its installed libraries in the virtual environment. And then we're running Flask, which is that app that's installed. And then this is just the Flask run to run like the basic app, right? So now we have this development server running for Flask that we set up. We can open a web browser to this. And you can see we hit the default. Here, if we go to this, there's a default route at the home of the URL, right? And it should return hello world, and it does. So the simplest app there is, right, is a hello world in a web browser. But we have a working Flask app now, based on us specifying that Flask as a dependency. The other thing we can do, if you rather not type in Poetry run each time, you can type in Poetry shell. And what this is going to do is launch a new shell, and it says, hey, the virtual environment was already activated. And now we should be able to just Flask app run already. And so that's kind of activating the virtual environment in that location. Normally, I think if we deactivate, you would. It should be able to deactivate. I'm not sure why that's not working, but yeah. So Poetry is running, and it allows us to do that. So typing Poetry shell should give us a new command prompt. And if we actually close our terminal and terminate that, I think if we create a new one, maybe you'll see the virtual environment created. It should say it's spawning a new shell is what I was expecting. Yeah, so it's a spawning shell with a virtual environment and loading personal and system profiles. And then in the parentheses here before, I'm using PowerShell, but it's the same thing would happen, if you're using Bash or some other shell on another operating system, it's showing that this virtual environment is activated here on the left-hand side. Yeah, so then once again, you can run your app with your virtual environment activated. And then if I type in deactivate, you can see the virtual environment went away. And now I should, if I try to run Flask app run again, yeah, I guess it's still running, but it allows you to activate and deactivate the virtual environment. Okay, so we have created a simple Flask app. It's running. What if we want to add some more dependencies? So like, hey, I'm going to use, say, PyTest for testing my app as an example. So you can do that directly on the command line. You could say Poetry add, and I want to add a group. And so we're going to do a group dev and put in PyTest. So I want to add PyTest as a dependency. And I want to add a development group. So if I'm running, say, my Flask app on the web in production, that I don't need PyTest installed, but only if I have like a development setup where I'm actually like working on the app itself, right? So it did what we'd expect. It actually already installed everything. It added PyTest as a dependency. And you can see that it added this new section. So poetry.group.dev dependencies, and it added PyTest as a dependency as well. We could also add other dependencies. So like, hey, I'm writing documentation for my app. You can add like a group called docs or something and install Sphinx, which is a common Python documentation system. And so it's installing all the dependencies Sphinx has. And also added a new group there as well. Why this is nice is like, hey, I'm just like, say, I need to rebuild my Sphinx documentation. You don't have to install all the dependencies. If you have a lot, you could specify, hey, I just want to install docs. So for example, we'll say Poetry install, and we want to do only docs. And then the -- sync means if anything above just those dependencies exist, remove those instead of just keeping them. So the sync makes sure that I'm asking for only docs and everything in my virtual environment matches just those dependencies. So we can run that, and what it's going to do is it's saying it's removing 8 dependencies. So it's going to remove Flask, it's going to remove Sphinx and all their dependencies, and it's just going to leave Sphinx installed. Okay, so we removed everything but docs. So we could run Sphinx now, but we can't run our Flask app anymore, for example. Now, if you want to get back, you can just type Poetry install. Or you could say, hey, Nick, now we want to like install everything but docs or something, right? So now we're going to reinstall, I think, without, instead of except, it should be without, I think is the thing. So we're going to install without docs, and then it's going to reinstall everything from Flask and PyTest, but remove the Sphinx dependencies and Sphinx itself. Okay, so we've shown how to add dependencies, add groups that allows us to split up our dependencies a little bit, and have things that are just needed for production or just needed to rebuild their docs. So you can kind of manage your dependencies in groups like that to the specific versions you want. What we can also do poetry show. And a nice way to see your dependencies is through a tree. So what this does is show all the dependencies. So Flask depends on Click, and Click depends on Colorama, and Flask depends on It's Dangerous, and PyTest depends on Colorama as well, right? So you can see all the dependencies in kind of like a tree-like structure as well, which is pretty nice. So that's kind of like the poetry show. And you could also, if we decrease a version of our dependencies, like our dev dependency, we could say, hey, I want to install poetry 7.1.0. And let's say it's less than that. So we've changed this dependency. Now we want to update our dependencies. For some reason, I wanted to downgrade PyTest. Maybe I don't know. I found a bug. It's not working. That version's not working. I'm going to downgrade my dependencies. So when I type poetry update, it's going to go through and resolve all the dependencies and make sure they're all compatible with each other with the right versions. So it's looking at all your direct dependencies, all their dependencies, and resolving correct versions of all of them, and then rewriting a new poetry.lock for it. And it's taking a second to resolve dependencies. Is there any questions in chat or online from anyone?
Do you have to add like a requirements file at some point, or is it not a thing?
Yeah, hey, Yori, thanks for joining in the question. So there is no need for requirements.txt. So what the equivalent thing is of a requirements file is we've specified our dependencies in our pyproject.toml, and then the poetry.lock file has said these are the exact versions of all those dependencies and all the dependencies of those dependencies, and even all, in a tree-like structure. So even the dependencies of the dependencies of the dependencies are all locked, right? So there's no requirements.txt because we have specified effectively our requirements, all of our dependencies, and kind of locked them so that they're reproducible. So there is no requirements.txt needed anymore.
Is it like a Docker container sort of a thing? So like you just take a snapshot, and like this snapshot exists until like I update the PyTest to a new version, and then like you get a new instance.
Yeah, so Docker is actually creating using a container of say virtual machine like Ubuntu or something like that, and installing a whole environment like all of Ubuntu that it's running in. This is not as heavyweight as something like that. We're just specifying what our direct dependencies are. It's using pip under the hood to go get the files we need at the right versions, and it's kind of using this lock file to make the dependencies deterministic, right? So it's creating an environment and installing things, but it's really just using basic pip install and things pip install setup tools, all the stuff that's just kind of out of the box in Python. So it's not using like containers or anything like that.
Gotcha. Thank you.
Yeah, thanks, Yuri. So we have downgraded PyTest, and it says updating. You can see it actually went down in versions. And then another thing we could do is say like, okay, well, hey, am I using the latest versions? We know now that we're not, but we could see that. So we could go poetry show and latest. And so this is showing all the differences between what we have installed and what the latest versions are. And we know we don't have the latest version of PyTest, right? So PyTest, the latest version is 7.2.2, and we have a earlier version installed. And you can see that for all the dependencies on what version is the latest and which ones we have installed. And that can kind of help you keep your environment up to date or see like how out of date it is. If you don't care what the latest versions are, you could run Poetry update. But remember, if you have versions kind of pinned, then it may not, like this is never going to update PyTest because we said it always has to be less than 7.1.0. If we run Poetry update, it will stay at 7.1.0 because it will stay at a version less than 7.1.0 because that's the highest one will upgrade to, right? And so if we want to upgrade back to the latest version, we have to change our dependency here. Okay, so we've installed dependencies, added them, showed how like the different, you can track and show what the latest ones are. So that's kind of like on the dependency management side of thing and setting up a project and making use of other people's libraries and projects that you want for your project as well. So now we want to be able to also, I guess, build our project and make it available for others to make use of. So next up, we can say Poetry build. And we said there was two main distribution formats that Python uses besides just giving, handing someone a .py module or something. So the two distribution formats are sdist, a source distribution, and a Yeaw. So if we go open our location here, projects, we have this Flask tutorial. In this dist folder, there's those two files. So we type Poetry build. It created the distribution formats so that we could share them with others automatically. It built them based on our pyproject.toml. So if we open one of these distribution formats, so this is a tar.gunzip, and inside of it's a tar file. And you can see all it really has in it is a folder. And the folder has our Python files. It has this pyproject.toml, the README, and then it has a Flasker folder with our Python module. So that is this source distribution. And the only thing really unique is this package-info. So this is the metadata. And so we can open that and see what that looks like. But this is a common metadata format that's created in source distributions, and it has a metadata version, and then the name of the project, version, classifiers. So all that metadata information is included in the source distribution, and then it also includes the README. So that's kind of like what a source distribution is at a high level. It's like your code plus this metadata in a pkg-info file, right? These things are called trove classifiers, this metadata. And so it automatically added those that, hey, our project supports Python 3.11, and it's got MIT license, and it requires Python greater than or equal to 3.11 and less than 4.0. And that comes directly from our pyproject.toml that we had an MIT license, and that our Python version is 3.11 or above, but less than 4.0. So it automatically included that in the metadata information. So when someone goes and if you were to upload this source distribution to the internet, then pip is able to read that package info and know what's compatible to install. And if you try to install it on an incompatible Python version or something like that, it would know that it can't install that. The second file it created is a Yeaw. This is the binary format. We just have pure Python, so we don't necessarily need a binary, but the Yeaw format's really nice nevertheless. It's got a .whl extension, but really this is just a zip file. So we can open this with 7-zip as well. And it's got similar information. So it's got the Flasker folder with the Python file. And then it's got this Flasker, the version, and dist-info folder in it. And it's got 3 pieces of metadata in it. If we look at those real quick, so there's a record file. So this is a listing of all the files in the distribution, in the wheel itself. And they got a SHA-256 hash. So it knows that everything is correct in the wheel file. And then it's got, and it even includes the metadata in its metadata as well. So this is this record is a recording of everything that's in this package. And so the wheel metadata file, so it's telling you, hey, the wheel version we're using, it knows we use poetry-core to generate it. Root is pure lib, and that's based on some Linux distributions use like this pure lib versus like a system version of Python, and installs certain libraries to a different place. So if your project is all Python, it will install it to one location on Linux. Some distributions do that. And if it depends on the other dependencies like, I don't know, GTK or Qt or some other dependency that would be installed with Linux, it will install it into a slightly different location. So that's what that's for. And then this tag is saying this is a Python 3 project, and it's pure Python, so it doesn't have any architecture constraints. But if you were compiling a wheel that included C code or something like that, then you might have a constraint on the architecture it was compiled from, and you might have to build a separate wheel for each architecture. So that's what that wheel file is. And then there's also a metadata file that is very similar or exact to the metadata file, the package-info we saw in the source distribution, right? So that's like what a source distribution of wheel is. It's just a zip file or a target gun zip of either compiled source code in the .wheel with metadata, or just a source distribution of the Python files with a little bit of metadata as well. All right, that was fun. We took a little dive into what the package formats look like for Python, and that's what it downloads. If you pip install something, it's downloading, prefers the wheel file. But if that's not available, it'll download the source distribution as well, and try to build it once it downloads it. Okay, what if we've built these files, and the whole reason to build them is then if we go back to our presentation we showed earlier, remember, you built your distribution, now you want to put it in a software provider for others to download. So the way you can do that with Poetry is you can run Poetry, you can do publish, and we have a repository. And by default, if you just type Poetry publish, it would try to upload it to PyPI, and you need to log in with your PyPI credentials or set up, I guess, your a token to upload. So for example, this is PyPI. You could set up an API token to use it, or just log in with your username and password. Obviously, a token would be a little bit more secure. And this is test.pypi.org. So the whole purpose of this one, instead of the regular one, is like you can test uploading stuff to it. And if someone pip installs a package, they're not going to like accidentally get your like test package or something like that. Someone would have to like purposely be trying to use this test PyPI repository. So what this is really fun with is you can create some like sample project, or just want to check out like, hey, how do I, go and upload my distribution to a software provider? You can use a test one as much as you want and upload, kind of a practice project in there. So I already created an API, a token for uploading stuff. And I set it up to use this test PyPI URL. So we can go ahead and get Poetry publish. And it says, uploading Flasker, and it's uploading this wheel, and finished uploading the wheel. So it uploaded the wheel file. We got an HTTP error. Method post is not allowed for this resource. So I might have my repository URL incorrect or something. I'll try. Maybe we're supposed to use the legacy one. Let me try to publish again. If that doesn't work, I don't know. Yeah, maybe. Okay, so it's saying, so it is working now. It's saying I'm not allowed to upload to Project Flasker, and that's probably because if we search for this, someone already uploaded someone already uploaded an app called Flasker. So I could change the name of our app and try again, or call it Flasker 2 or something. But and if people want to see that, we could. So I guess we could just change the name, right, and then rebuild. So let's do poetry install. And I think we need to refactor and rename this directory to Flasker 2 maybe as well. Okay, so we rebuilt it. It's rebuilding the project and calling it Flasker 2 now. And then let's republish it and see if that works again. And then in PyPI, anyone on the internet can go out there now. And it's actually uploading, once again, the wheel and that source distribution. So if we go search for Flasker now, there's a Flasker 2, and it says Hello World Flask app. That's the one we just uploaded less than 20 seconds ago. And so if someone wanted to pip install this, they could type in pip install -i to the test repo and type in Flasker 2. And if everyone recalls, the mistake I had in my repo is I had a -simple as my URL, but for uploading, the right URL was the /legacy was the URL to use to configure the repo. So what I did is do poetry config, and then this is this test PyPI repository that I added. If you just type poetry publish without anything else, without like a repo or anything, that would upload to the real PyPI, and you'd have to have an account there. And once again, you can't clash with any names or anything. So we've just published a app to here. People can download it, right? So we have put our app up here in this software provider, and we've put a source distribution and a wheel. So now anyone could pip install this Flask app that we just made with all of our dependencies, and pip install it, and you would get it with Flask and the other dependencies installed, and you could run our Flask app. So if we go back to kind of what we wanted to go through, so we installed packages, we managed our application dependencies, and we also packaged our Python project and published it to the internet. So that's all pretty fun. And I also showed us how we update a project and install dependencies, which created the lock file, and create everything you need for like a Python project using Poetry. Now notice we didn't manually create a virtual environment for our dependencies. There's no requirements.txt file. We didn't install any other tools. We just used Poetry for doing all of those things. So it is really like this nice way to project manage your whole app or library that you're building using kind of one tool. And you can use pipx to install it so that it's available across all your projects. And you can always create a pyproject.toml now and get rid of your setup.py and a bunch of other configuration files and your requirements.txt file and all that kind of legacy stuff, and just have the pyproject.toml. That's kind of what I wanted to go through with everyone today. Is there any questions about any of that?
Great job, Dan. This was really interesting. Thank you.
Yeah, thanks, Mike.
Hey, Dan, thank you also for this presentation. I'm wondering, are there any tools out there that can help us do a quick quick static analysis on this pyproject.toml file.
So you're kind of like making sure that the formatting of it's correct. Is that right?
Yeah, the formatting and even like some of these sections, these names are, quite long. And, if I wanted to just validate my file, if there's a quick tool to support that, check.
So one thing I like to do, let me open like another project. I'm a big fan of pre-commit, and I don't want to like go too far into pre-commit, but what pre-commit does is anytime you commit changes to like your Git repository, it will check that everything is correct and kind of do an analysis, formatting, run, yes, check for type hints, anything that you want to do on your project before you commit. The way to set that up is you create this .precommit-config.yaml, and there is one there's a hook for that for check toml, which is one of those out of the box pre-commit hooks. So then if you have there's quite a lot of projects I have here. So there's like black for code formatting, MyPy, and actually, if we go to Git status, so we're on I guess we could check out our main branch. And if we pull the new version, I think there's actually like probably newer, I haven't updated this in a while, but there's newer versions of these things that I've started using. So they're still black, but I've been using rough a lot, and the rough replaces like Flakegate and a whole bunch of other like static checking tools. And it's actually written in Rust and is very fast, so it can like check your whole project. So once you have this installed, and I can activate the virtual environment, you can type pre-commit run and like all files. It would also run on any changes that you've made as you're committing. And what it's doing is actually setting up. It only does this every time you change your pre-commit dependencies, but I just updated them all, right? So it's creating an environment for check and formatting tools like Black and MyPy and Rough and all these other things, and initializing an environment for them. It just has to do this once again, and then it would be set up for then on. And then it's going to go through all of our files and check that they're correct. And I know you asked just about TOML files, so there's a check for that as well, but you can also add a lot of other checks on that as well.
Cool, thank you for the tip on check TOML.
Yeah. Any other questions, anyone, about anything? I guess we'll, as it's initializing environments to check all the code. What's really nice about using pre-commit is you can set up all these rules for, hey, auto code formatting, static checking your code, all this type of stuff. And then if you're working on like an open source project, everyone will have those same settings. And so it's very nice not to have any discussions about like code style or, hey, I would have used single quotes instead of double quotes or stuff like that. It's just like taken care of. And then all the discussion on like someone's pull request is all about how they implemented it rather than like formatting or style or stuff like that. So yeah, it's really nice not have to worry about that. So all right, so that was kind of like a side discussion about pre-commit, which wasn't necessarily part of poetry, but yeah, any other questions, anyone?
Are there sort of like size limitations or like constraints in that sense?
Size constraints on like how many dependencies you can have in your pyproject.toml. Is that what you mean, Yuri, or something else?
No, just like, I mean, I'm assuming you can make a 500 megabyte app and then start like uploading it to have people download it through pip install. I'm sure that it's not. Is there some sort of like a guideline, or is there it's basically like you shouldn't do it?
I don't think there's any guidelines or anything like that. Obviously, you know, having people download larger files is going to take more time. If we go to like our Flasker source distributions and stuff, like these are tiny, like 2 kilobytes, right? So it created like, I mean, we didn't have much code in there, but it packaged all of it into a, very small file, right? I think the only time you might have a little bit larger ones if you're packaging, you know, images and icons, and have to, I guess, include other like other types of source code or binaries or something with it. But a lot of times, I guess I have never seen that like as an issue, or libraries take necessarily a long time to download. Sometimes if there's not a wheel, it could take a while for a project, a library to compile, because it has to actually rebuild the project, and you have to have the right dependencies and stuff if it's just a source distribution. But I haven't really seen too much on like the size. I don't think I'm not aware that PyPI has some type of size limitation, or at least doesn't have if it does, it's a reasonable size of limitation or something like that, right? So
Thank you.
yeah, thanks, Yuri. Any other questions, anyone, about poetry? Everyone excited to go get rid of your setup.py and requirements.txt file?
Yeah, no, I'm definitely gonna make one. It looks pretty cool. Like we kind of cool to install your own pip install. I don't know what I'm gonna make, but yeah, no, I think it's a very cool presentation. I think it's very very interesting. I never knew that like it worked like this, but like it's very very interesting.
Great, thanks, Yuri. If I will mention, if poetry for some reason is not your cup of tea, there is no shortage of packaging tools for Python. So there's other ones that make use to pyproject.toml. There's other things for uploading packages like Flit and others. So if for some reason poetry is like, I don't know, this isn't jiving with my flow or something, there's definitely some other options as well. But I really like this as kind of this single tool you can use for everything. I like it a lot. So. All right, if there's no other questions, I'll go ahead and stop recording.